My heart's on stereo, chemistry is what I know. Wedges or dashes fill that hole. Oh, 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 oh. So much better than regio. Can't wait to practice it some more. Chemistry is what I do, so just watch my skills at stereo.
OMG, WTF are you doing?
Singing about stereochemistry and giving fellow students something to bop to.
Nobody has bopped since 1950. And most of us just want to save babies and make lots of money doing it. But Professor Reck told us we could not make it to med school unless we know the difference between regio-selective and stereo-specific reactions. I don't even know what those words mean.
No problem. I'd be more than happy to explain. Stereospecific relates to the 3D arrangement of atoms in a chiral molecule. If a reaction mechanism produces only one 3D arrangement, then it is considered stereospecific. For example, SN2 reactions are stereospecific because they only back side attack. E2 mechanisms are stereospecific when there is only one beta hydrogen. Catalytic hydrogenation and hydroboration oxidation are also stereospecific. On the other hand, if a reaction is stereoselective, it will make both stereoisomers but in unequal amounts. This occurs in E1 mechanisms and E2 mechanisms with two beta hydrogens. Steric and electronic effects help determine which product is favored. If there is an approximately equal mix of stereoisomers, then the solution is considered racemic.
So if stereo-specific and stereo-selective refer to different 3D arrangements of the same molecule, then what does regiochemistry have to do with it?
Regiochemistry has to do with the arrangement of bonds made between the atoms in a molecule after a reaction has taken place. When the products of a reaction can contain constitutional isomers, then you have to think about the regiochemistry. Some reactions like E1 and E2 favor one constitutional isomer over another, and this makes them regioselective. For these reactions, the selected product will typically be Zaitsev, or the one where the alkene's double bond is most substituted, although this can sometimes be reversed when a bulky base is used. Another regioselective reaction is hydrohalogenation, but the preferred product is Markovnikov, or the one where a halide is added to the most alkyl substituted position. But this as well can often be reversed by using a peroxide to give you an anti-Markovnikov product.
So if a regio-selective reaction forms multiple products, but just with a preference, does a regio-specific reaction only form one product?
Exactly. While most of the reactions we have learned so far are regioselective, there have been some regiospecific ones. Oxymercuration demercuration is one example. This is because it has no rearrangement, and also, for any given molecule, the mercury ion will always break its bond with the most electrophilic carbon it is attached to.
Wow. Thanks for all the help. Now I just need to figure out what pi bonds are.
Sorry, but I don't have the time to explain all of organic to you. However, the information I just told you is a good start. Now, just practice, 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 and perhaps you'll get to the point where you can sing songs about the subject too. By the way, would you like to go out with me sometime?
Sorry, but I don't date chemistry nerds.
Fine, because I don't date blonde chicks who sound like robots.